Biology students. Today we're going to talk about our different types of body systems. So we're going to talk about how cells, tissues, organs, and then how these organs play in these larger systems. So this is a quick overview of the next unit that we're going to talk about. After this, tomorrow we're going to start learning about digestive, and then eventually on to the circulatory in reference to just specifically the heart. Okay. All right. So organization of the body. Here we go. We're going to learn how different cells come together and form organs and organ systems. And then finally, we're going to end our lesson on homeostasis. So since we are in the kingdom animals, we are eukaryotic. So we have a nucleus and we have organelles in our cells. In addition, all animals are multicellular. And what happens when all of these cells start working together? Well, we're going to get tissue. And if you were to divide our animals' tissue into 4 categories, the first one would be epithelial. Okay, so the example here is skin, lining of the digestive system. And again, it's used not only for protection, but also absorption and excretion. The second tissue, okay, it's called connective tissue, and that's easy. It just helps support structures. So we're thinking of like cartilage and all the stuff like that. So anywho. Next one is nervous system. Well, that's pretty easy. Your nerves. Okay, so the nerves are in charge of sending signals. Again, they are not used for protection, and nerves are not used for absorption, nor are they used for structural integrity. So that's the connective tissue aspect. Nerves are just for cell signaling. So you think of the brain, you think of the central nervous system, you think of the peripheral nervous system, anything that deals with communication. Okay, it looks like a spider web, but it is not as strong as a spider web. Nerves are very, very delicate. And then lastly, muscle. Most people think muscle as skeletal muscle, which is involved in moving your skeleton. However, think about all of the involuntary movements. Think about your digestive tract. Your food goes through your digestive tract, and that movement is facilitated by these muscle tissue. All right. Now, there are many, many, many different types of organ systems, but in this unit, we are going to focus on the nervous system. Okay, so we're going to skip integumentary. Thank you. Sorry, the tongue twister. We are going to skip that system. I'm not even going to try to pronounce the second one. All right, and we're going to in this unit, we're also going to talk about the immune system. What a great time to talk about the immune system with the COVID virus out and about. Additionally, muscular system is very, very easy. If you want to learn more about this, I highly recommend you taking our anatomy and physiology class here at Lake Highlands. Circulatory, I think, is one of my favorites because I love learning about how the heart and lungs work together and circulating oxygen and CO2 around our body. And then lastly, our skeletal system. Again, if you were to take anatomy and physiology, you're going to be a lot more, you're going to go in a lot more depth for skeletal and muscular systems. But we're just going to kind of skim the surface. All right, so in terms of respiratory system, think of just the lungs, okay? The respiratory system starts with the mouth and ends at the lungs and then goes outside the mouth again. Digestive system, tomorrow we're going to talk about the ins and outs of the digestive system. Fun stuff, huh? Excretory, that's how it's think of digestive system as absorbing, in eliminating waste. Excretory is just removing waste. Okay, so your liver and kidneys are mainly there just to help excrete waste. In addition to the liver producing some enzymes for digestion. So the liver, if you notice right here, we do have a little bit of overlap. We have the liver is a great filter. So think of excretory as filtering systems. Your kidneys, not involved in digestion, that is involved mainly in just excreting waste in the form of urine. But we have the liver right here. In addition, we have the liver has multiple jobs in it, helping with digestive enzymes as well as excretion. Endocrine, think of endocrine as hormones. We're going to talk about that later in the unit in terms of reproductive organs. All right, so briefly, digestive system. Okay, mouth, going through the esophagus. We are going to eventually go into the stomach, and then the stomach is going to empty its contents into the small intestines. Where the small intestines meet, that's where the liver and gallbladder are going to excrete some digestive enzymes. And then finally, we're going to go up the large ascending colon and then all the way down and through the rectum. Okay, so it takes a tipsy-turvy little adventure here from start to finish. All right, let's go through here. All right, so it's important to note that your digestive system isn't just like this rubber tube. It has all of this surface area, and the main purpose of all the surface area is for absorption. So we've got all these folds. It may look like a thin tube, but inside this tube, we have all these little microvilli full of capillaries, and this helps with absorption. More surface area, better absorption. All right. Excretory, again, our lungs are involved in excretory. Excreting waste, think of excreting CO2. You're exhaling CO2. Liver, again, is involved in excreting. It's a great filter. Your kidneys going through your ureter, and then everybody has got this little bladder at the very bottom of your body, and it's going to excrete urine. Okay, so again, anytime you hear the word bladder, it is mainly just a storage compartment. Think of gallbladder; it stores things. Okay, urine bladder stores urine. All right, there's our liver. We have kidneys. We have the ureters. Often people get the word urethra and ureter mixed up. Okay, you have one ureter. I'm sorry. Yep. Sorry, you have one urethra. I'm getting it mixed up, and you have two ureters. All right. Now we're going on to circulation. This is the heart. Pretend we have. Let me go back here. Pretend we have two lungs on either side of this heart. Blue represents deoxygenated blood. No, you do not have blue blood, but it definitely helps with the color here. So again, we're going to go a little bit more in depth later on with this, but essentially we have two entrance points into the heart. We have the inferior vena cava for all of the blood coming from the bottom part of your body, and then we have the superior vena cava coming from the upper torso. So it's going to enter in your right atrium, and it's kind of flip-flop because you would think that the left-hand side of the picture we would call that left, but no, this is when a person is facing you. Okay, so we have the right atrium that's going to come in here. Then it's going to go down the right ventricle. The right ventricle is going to pump the deoxygenated blood to the hearts on either side, okay? And then they're going to interface at these capillaries. So where veins and arteries interface, we call those capillaries, and that's what your lung is, just one giant mesh of capillaries. After the blood gets oxygenated by the lungs, it's going to come back, and it's going to come back at one entrance point. Okay, so this is going to be your left atrium, even though it's on the right hand side. Imagine the person's facing you. So this is going to be the left atrium, and then it's going to come down to the left ventricle. And the left ventricle, this is not drawn to size because the left ventricle should be a lot bigger, and you're going to have all this thick muscle, because this thick muscle is responsible for pumping blood out of the heart into the entire body. So quick overview. It gets a little bit more complicated than that with all the valves, but that's essentially what the heart does. Now, this is a blood vessel. So you could have an artery as a vein. Both are blood vessels. And again, you're not going to have all of that epithelial tissue in your blood vessel. So let me go back. You're not going to have all of this villi, all this surface area in your blood vessels. Think of this just for absorption. We go back. We're going to have smooth tubes for our veins and arteries. So this is where they interface. Okay, it's not just connected with one big tube and it goes right through the lungs. The lungs are filled. It's this massive network of capillaries, and it's going to transfer. And this is where we're going to have that oxygen exchange right here in the lungs. Okay, so then we're going to have an artery that's going to be oxygenated blood. Here is an example of a capillary. So, for example, it's not on my finger anymore, but I slammed my finger, and you see all these little dots all over my finger. I slammed it in the door. I think they all kind of healed up. Now you still see some little dots. Or sometimes when somebody has like bloodshot eyes, they've burst their capillaries. And this is just an example of what's happening in your body, having a little bit of homeostasis to fix it. So we have capillary walls break for whatever reason. We have platelets come in, and then we are going to have that clot form. All right. In terms of the respiratory system, we're just going to focus on the lungs here. So again, through the nose or mouth, this is going to go through a different tube. You have two tubes going down your throat. You have one for food and one for breathing. You do not want to mix those two together, okay? Otherwise, you will be choking. So this is the trachea. This is like a corrugated tube. And if you kind of feel it, you can kind of feel your throat a little bit. This is when you touch your throat, this is part of your larynx that I'm feeling right now. And it's hard. There's cartilage ribbed around it. It's not soft. Your esophagus the food, let's go down your esophagus here. Let me go back. The esophagus, you have two tubes that branch off. Your esophagus is smooth. It's got all of this muscular tissue that helps push food down. But your trachea is going to be pretty tough, okay? It's going to go down into your lungs. Now, what helps pump the lungs? We've got this muscle that sits right underneath the lungs called the diaphragm. Okay, so this muscle right here, diaphragm, is involved at contracting. So when it contracts, it gets really small and it allows the lungs to fill up. And then when it relaxes, when you relax, the muscle relaxes, gets wider and you get to exhale. So let's practice right now. We are going to squeeze our diaphragm. So we're going to inhale. It takes a lot of energy because you're squeezing that muscle. And then when we exhale, we're relaxing the muscle. We're relaxing the diaphragm. And when we relax muscles, the muscle gets a little bit thicker and it pushes the lungs up. Okay. Again, we're going to have this spider web of capillaries and veins and arteries, and this is what's inside. We have all these little alveoles where we have the O2 and CO2 interface. Again, here's your breathing. You have a diaphragm, and it's going to expand when you exhale, and it's going to push the lungs up, and it's going to push the air out. Lastly, it's important to note that our body is constantly in a state of homeostasis. It's constantly having things turn off and turn on, much like your AC unit in your household. So, for example, if you have your thermostat set for 74, which I do, the temperature, if it gets above 74, you're going to have that thermostat kick on, okay? And then, the temperature is going to kick on. My AC is going to turn on my AC unit, and it's going to drop the temperature down below whatever setting. Maybe I have it set for 70, so I have it set within that little window, the little margin. And then when it gets below 70, it's going to turn back off, and then eventually it's going to get hot again. And then my AC unit is going to turn on. It's going to drop it back down. So it's constantly in this state of turning things on, turning things off. Okay. For example, when it's cold outside, your body is going to recognize that it's cold, and your brain is going to send signals to different parts of your body to start heat production. One of the fastest ways for your body to start heat production is to start shivering. Conversely, if you're really, really hot outside, for example, if you're playing soccer like this girl in the picture, you don't want to start shivering. You want to do the opposite. So your body's going to start turning on a different system because you're too hot, and you're going to start perspiring and exhaling all the heat out. Okay, so again, your body's going to turn on a different system. And then when it gets when your threshold, your body temperature gets to the point where it wants, again, you're going to stop sweating, okay, because you don't want to continue losing all that heat. Okay, so again, your body is constantly in a state of homeostasis, constantly turning things on and constantly turning things off. I hope this is helpful, and good luck.